executive at Facebook during a period of a lot of scaling in the company history. I mean, it's actually a fascinating period of human history in terms of technology. Well, in terms of human civilization, honestly. What did you learn from that time about what it takes to build and scale a successful tech company, a company that has almost immeasurable impact on the world?
That was an incredible moment in time because everything was so new. To your point, like even how the standards of Web 2.0 at that time were being defined, we were defining them. I mean, I think if you look in sort of the if you search in the patents um, patent library, there's a bunch of these patents that like me and Zuck have for like random things like cookies, or like cross-site JavaScript, like all these crazy things that are just like these duh kind of ideas in 2023. We had to invent our way around. How do websites communicate with each other? How do we build in the cloud versus in a data center? How do we actually have high performance systems?
You mentioned data science, the term and the
We had to,
idea.
we invented this. I invented this thing called data scientist because we had a PhD from Google that refused to join because he got a job offer that says data analyst.
Yeah.
And so we said, call him a scientist because he was a PhD in particle physics. So he really, he was a scientist. And I said, great, you're a scientist here.
And that launched a discipline.
That launched a
I
discipline.
mean, a term, what's arose by any other name, but yeah, like, sometimes words like this can launch entire fields. And it did in that case. And you didn't, I mean, I guess at that time you didn't anticipate the impact of machine learning on the entirety of this whole process, because you need machine learning to have both ads and recommender systems to have the feed for the social networks.
Exactly right. The first real scaled version of machine learning, not AI, but machine learning, was this thing that Facebook introduced called PYMK, which is People You May Know. And the simple idea was that can we initiate a viral mechanic inside the application where you log in, we grab your credentials, we go to your email inbox, we harvest your address book, we do a compare, we make some guesses, and we start to present other people that you may actually know that may not be in your address book. Really simple, a couple joins of some tables, whatever. And it started to just go crazy. And the number of people that you were creating this density and entropy inside this social graph with what was some really simple basic math. And that was eye-opening for us. And what it led us down this path of is really understanding the power of like all this machine learning. And so that infused itself into newsfeed, and how the content that you saw could be tailored to who you were and the type of person that you were. So there was a moment in time that all of this stuff was so new. How did you translate the app to multiple languages? How do you launch the company in all of these countries?
How much of it is just kind of stumbling into things using your best, like, first principles gut thinking, and how much is it like 5, 10, 15, 20-year vision? Like, how much was thinking about the future of the internet and the metaverse and the humanity and all that kind of stuff? Like, because the news feed sounds trivial.
I'll say something,
but that's like changes everything.
Well, you have to remember, like, news feed was named, and we had this thing where we would just name things what they were. And at the time, all of these other companies, and if you go back into the Wayback Machine, you can see this, people would invent, an MP3 player, and they would come up with some crazy name. Or they would invent a software product and come up with a crazy name, right? And it sounded like the pharma industry, blocazimab, tag your best friends.
Yeah.
And you think, what is this? This makes no sense. And, this was Zuck's thing. He was like, well, this is a feed of news, so we're going to call it news feed. This is where you tag your photos, so we're going to call that photo tagging. I mean, literally, pretty obvious stuff. So the way that those things came about, though, was very experimentally. And this is where I think it's really important for people to understand. I think Bezos explains this the best. There is a tendency after things work to create a narrative fallacy because it feeds your ego.
Yeah.
And you want to have been the person that saw it coming. And I think it's much more honest to say we were very good probabilistic thinkers that tried to learn as quickly as possible, meaning to make as many mistakes as possible. I mean, if you look at this very famous placard that Facebook had from back in the day, what did it say? It said, move fast and break things.
Mhm.
In societal language, that's saying make mistakes as quickly as you can. Because the minute you break something, you don't do that by design. It's not a feature. Theoretically, it's a bug. But he understood that, and we embraced that idea. I used to run this meeting once a week where the whole goal was I want to see that there was 1,000 experiments that were run and show me them all from the dumbest to the most impactful. And we would go through that loop. And what did it train people? Not that you got celebrated for the right answer, but you got celebrated for trying. I ran 12 experiments, 12 failed. And we'd be like, you're the best.
Can I just take a small tangent on that? Is that move fast and break things has become like a catchphrase of the thing that embodies the toxic culture of Silicon Valley in today's discourse, which confuses me. Of course, words and phrases get sort of captured and so on.
Becomes very reductive. That's a very loaded set of words that together can be, many years later, people can view very reductive.
Can you steelman each side of that? So
yeah,
pro move fast and break things,
Yeah.
and against
Yeah,
move fast
absolutely.
and break things.
So I think the pro of move fast and break things is saying the following. There's a space of things we know and a massive space of things we don't know. And there's a rate of growth of the things we know, but the rate of growth of the things we don't know is actually, we have to assume, growing faster. So the most important thing is to move into the space of the things we don't know as quickly as possible. And so in order to acquire knowledge, we're going to assume that the failure mode is the nominal state. And so we just need to move as quickly as we can, break as many things as possible, which means like things are breaking in code, do the root cause analysis, figure out how to make things better, and then rapidly move into the space. And he or she who moves fastest into that space will win.
It doesn't imply carelessness, right? It doesn't imply moving fast without also aggressively picking up the lessons from the mistakes you make.
Well, again, that's steel manning the pro, which is it's a thoughtful movement around velocity and acquisition of knowledge. Now let's steel man the con case. When these systems become big enough, there is no more room to experiment in an open-ended way because the implications have broad societal impacts that are not clear upfront. So let's take a different, less controversial example. If we said, Lipitor worked well for all people except South Asians, and there's a specific immunoresponse that we can iterate to, and if we move quickly enough, we can run 10,000 experiments, and we think the answer is in that space. Well, the problem is that those 10,000 experiments may kill 10 million people. So you have to move methodically. When that drug was experimental and it wasn't being given to 500 million people in the world, moving fast made sense because you could have a pig model, a mouse model, a monkey model. You could figure out toxicity. But we picked all that low-hanging fruit. And so now these small iterations have huge impacts that need to be measured and implemented. Different example is like, if you work at Boeing and you have an implementation that gives you a 2% efficiency by reshaping the wing or adding winglets, there needs to be a methodical move slow, be right process, because mistakes, when they compound, when it's already implemented and at scale, have huge externalities that are impossible to measure until after the fact. And you see this in the 737 MAX. So that's how one would steelman the con case, which is that when an industry becomes critical, you got to slow down.
This makes me sad because some industries, like Twitter and Facebook are a good example, they achieve scale very quickly before really exploring the big area of things to learn. So you basically pick one low-hanging fruit and that became your huge success, and now you're sitting there with that stupid fruit.
Completely. Well, so you're I think so as an example, like, if you had to, if I was running Facebook for a day, the big opportunity, in my opinion, was really not the metaverse, but it was actually getting the closest that anybody could get to AGI. And if I had to steel man that product case, here's how I would have pitched it to the board and to Zuck. I would have said, listen, there are 3.5 billion people monthly using this thing. If we think about human intelligence very reductively, we would say that there's a large portion of it which is cognitive, and then there's a large portion of it which is emotional. We have the best ability to build a multimodal model that basically takes all of these massive inputs together to try to intuit how a system would react to all kinds of stimuli. That, to me, would have been a profound leap forward for humanity.
Can you dig into that a little bit more? So, in terms of, now this is a board meeting, how would that make Facebook money?
I think that you have all of these systems over time that we don't know could benefit from some layer of reasoning to make it better. What does Spotify look like when, instead of just a very simple recommendation engine, it actually understands sort of your emotional context and your mood and can move you to a body of music that you would like? What does it look like if, your television, instead of having to go and channel surf, 50,000 shows on a horrible UI, instead just has a sense of what you're into and shows it to you? What does it mean when you get in your car and it actually drives you to a place because you should actually eat there even though you don't know it? These are all random things that make no sense a priori, but it starts to make the person or the provider of that service the critical reasoning layer for all these everyday products that today would look very flat without that reasoning. And I think you license that and you make a lot of money. So in many ways, instead of becoming more of the pixels that you see, you become more of the bare metal that actually creates that experience. And if you look at the companies that are multi-decade legacy kinds of businesses, the thing that they have done is quietly and surreptitiously move down the stack. You never move up the stack to survive. You need to move down the stack. So if you take that OSI reference stack, right, these layers, how you build an app from the physical layer to the transport layer all the way up to the app layer, you can map from the 1980s all the big companies that have been created, right? All the way from Fairchild Semiconductor, NatSemi, to Intel, to Cisco, to 3Com, Oracle, Netscape at one point, all the way up to the Googles and Facebooks of the world. But if you look at where all the lock-in happened, it's by companies like Apple, who used to make software, saying, I'm going to get one close. I'm going to make the bare metal, and I'm going to become the platform. Or Google, same thing. I'm going to create this dominant platform, and I'm going to create a substrate that organizes all this information. That's just omnipresent and everywhere. So the key is, if you are lucky enough to be one of these apps that are in front of people, you better start digging quickly and moving your way down and get out of the way and disappear. But by disappearing, you will become much, much bigger, and it's impossible to usurp you.
Yeah, I 100% agree with you. That's why you're so smart. This is the depersonalization and the algorithms that enable depersonalization, almost like a operating system layer. So pushing away from the interface and the actual system that does the personalization. Yeah. I think the challenge is there's obviously technical challenges, but there's also societal challenges that it's like in a relationship. If you have an intimate algorithmic connection with individual humans, you can do both good and bad. And so there's risks that you're taking. Yeah. So if you're making a lot of money now as Twitter and Facebook with ads, surface layer ads, what is the incentive to take the risk of guiding people more? Because you can hurt people, you can piss off people, you can, there's a cost to forming a more intimate relationship with the users. in the short term, I think.
You said a really, really key thing, which was a really great emotional, instinctive reaction, which is when I said the AGI thing, you said, well, how would you ever make money from that? That is the key. The presumption is that this thing would not be an important thing at the beginning. And I think what that allows you to do, if you were Twitter or Google or Apple or Facebook, anybody, Microsoft, embarking on building something like this, is that you can actually have it off the critical path. And you can experiment with this for years if that's what it takes to find a version one that is special enough where it's worth showcasing. And so, in many ways, you get the free option. You're going to be spending, any of these companies will be spending tens of billions of dollars in